Hey, welcome. Today, we're going to dig into a topic that's, well, literally foundational to our lives, but it's something we almost never think about: the health of our soil. It's the silent, living resource that really does sustain us all.
I love this quote because it really hits the nail on the head. Soil is our silent partner in making all the food we eat, but the thing is, it's a partnership we've kind of taken for granted. And right now, that silent ally is in serious trouble.
So, just to give you an idea of the scale we're talking about, look at this number: 173.65 million hectares. That's the amount of degraded, underperforming land just in India alone. It's a massive, massive area that's producing way below what it could be, and believe me, this isn't just an isolated story. It's happening all over the world. Which brings us to the big question, right? What in the world is making the ground beneath our feet so sick? Well, let's dig in and find out. First things first, we need to be clear on what we actually mean when we say a soil is problematic. It's not just that a piece of land is naturally a bit infertile. It's more complicated than that. The key thing to remember here is that these soils have developed serious issues, often because of how we've managed them, that make farming basically unprofitable without some major intervention. And these problems, they really fall into two main buckets: physical and chemical. Okay, so let's start with the physical problems. These are issues with the soil's actual architecture. The stuff you can often see and even feel. And wow, the difference is just night and day. Healthy soil is kind of like a big fluffy sponge. It's full of tiny pores and channels that let water, air, and plant roots move around freely. But physically degraded soil, it gets all compacted and dense. It loses that sponginess and basically ends up suffocating the roots and blocking the water. One really common problem is something called surface crusting. Just imagine this. As the soil dries out, it forms this hard, almost cement-like crust right on top. Now, if you're a tiny little seedling trying to push your way through to the sunlight, that barrier can be absolutely impossible to break. It stopped growth right from the get-go. But what's maybe even sneakier is the subsoil hardpan. This is basically an invisible wall of super compacted earth buried deep underground. So a plant's roots grow down, they're looking for water and nutrients, and then, bam, they hit this layer and just stop. They can't go any further. They're totally cut off from everything they need to thrive, no matter how good the soil on the surface looks. Okay, so we've talked about the physical structure. Now let's switch gears and talk about the chemical problems. These are often completely invisible, but trust me, they are every bit as destructive. They fundamentally change the soil's entire chemistry. The two main chemical villains you'll hear about are saline and sodic soils. Here's an easy way to think about it. Saline soil has way too much salt. This creates what's called a physiological drought, meaning the plant is surrounded by water, but it literally can't drink it because the salt is pulling the water away. Sodic soil, on the other hand, has a toxic overload of sodium. And this sodium is a real destroyer. It wrecks the soil's structure, causing all the clay particles to spread out and clog up all the pores. And you can often spot them. Saline soils get that classic white crust, while sodic soils can sometimes get these dark, blackish stains on the surface. Okay, so I know this can all seem pretty bleak, but here's the good news. These soils can be healed. It's not a lost cause. It just takes understanding the specific problem and then applying the right solutions. So when we talk about reclamation, we're not talking about some simple, quick fix. The real goal is to restore that delicate chemical balance. For these damaged soils, it usually means we have to kick the harmful sodium ions off the clay particles and replace them with something beneficial, like calcium. So how's it actually done? Well, you can think of it like a simple three-step treatment for the soil. First, you apply a chemical amendment, which is usually a source of calcium, like gypsum. Second, you incorporate it. You plow it in to mix it all up. That calcium goes to work, kicking the sodium out. And finally, step 3, you leach it. You flush the soil with lots of clean water to wash all of that nasty, displaced sodium away for good. But hey, it's not always about chemical fixes. A huge part of the solution is just working smarter. This means choosing crops that are naturally tougher and more tolerant of these difficult conditions. You probably wouldn't try to plant super sensitive beans in a salty field, but you could have great success with something much more resilient, like barley or cotton. It's about picking the right plant for the job. So we've gone through the problems and some of the solutions, but let's just zoom out for a second. Why does all this technical stuff about soil chemistry and physics really matter to every single one of us? It really is this simple. Healthy soil is the absolute foundation of our ability to feed ourselves. The food that's on your plate tonight, the clothes you're wearing, it all starts with the soil. It's not just dirt, and it's definitely not an infinite resource we can just afford to use up. It's a living, breathing ecosystem, and it desperately needs us to protect it. So, we're left with this thought. We completely depend on this silent ally, but it's finite and it's fragile. The real question for all of us then is, how do we change the way we do things and the way we think to make sure we're protecting it for all the generations that come after us? Thanks for tuning in.